Okay, so the next question that we have on the menu today is asking us, how do we find the surface area of a rectangular prism? Okay, and what is a rectangular prism? Let's start there. So a rectangular prism is a shape that looks like this, and we're trying to find the surface area. So actually, I'm gonna redraw this out, and we're gonna try to we're basically gonna like unfold this. If this was like an origami project, and we unfolded it, it would look a little something like this. Let's use these shapes. So it says rectangular pyramid, so that's what the base is. So let's start by adding a rectangle like that, and then we need some triangles associated with this. So maybe we have a triangle like that. Okay, a triangle like that. Can I spin this? Okay, I can't rotate these triangles, thanks Microsoft Paint, so I guess I'll have to draw them by hand. Pardon me for the not perfectly straight lines. Okay, but you can see, like, if we were to unfold this rectangular pyramid, we would get a shape that looks like this. Kind of looks like a kite, kind of. But yeah, this is what an unfolded rectangular pyramid looks like. And since we're trying to find the surface area, it's pretty much just the area of this whole thing. Okay, so once we find the area of the mat or the net, this is what it's called. So this is an unfolded prism. Okay, so we have five sub like two-dimensional shapes that make up one three-dimensional rectangular pyramid, and if we find the area of all of them individually, we can find the surface area of the whole rectangular pyramid fairly straightforward. Okay, so here let's name our shapes. So let's say this is going to be R for rectangle. This will be T1. This will also be T1, because as you can see, the T1, those T1s are the same triangle. Of course, they're just like upside down versions of each other, but they have to be the same. Okay, so those T1s are the exact same triangle. And then T2, those are the exact same triangle, but they're different from the T1s. So the surface area is equal to R plus 2T1 plus 2T2. Okay, so let's think about some of the measurements that we're gonna need. So for the rectangle, we are gonna need these properties. So the distance here, that's one of the things we're going to need. Let's call that the length, and let's call this the width. Okay, so this is just going to be length times width. Okay, that's fairly straightforward to come by. We should really just be able to like take this triangular, or take this pyramid, take a ruler, stick it on the side of the base, and you can easily find length and width. Okay, and for the T terms, let's write that out. So maybe red for T1. So T1, we're going to need this measurement. And this, let's call that slant 1. Okay, the reason why we want to call that slant instead of like height is because you see okay, actually, nice, I have this calendar here. So this would be like one of the faces of like this could be like a pyramid type thing, or it's like a prism. I guess it's not a perfect model for a pyramid, but it's not the height. The height would be perfectly vertical, but we're actually looking for the slant over here. Actually, I'll make my camera bigger so you can see what I mean. Okay, so you see this is like a triangle here. the slant is this distance right here, but the height would be like if we were perpendicular to the ground. The height from there down, that is not the same as the slant. The slant is the diagonal distance, okay, which is going to be a little bit bigger than the vertical height. So that's why we want to call it the slant instead of the height. Okay, cool. So let's go back to the drawing board. Back to the drawing board. Okay, so this the area of that is the slant times the base, but that's just L. So it's going to be 1/2 slant times base. So this is going to be 1/2 length times slant 1. Okay, and for the second triangle, let's put that in blue. This is going to be slant number 2, and for this it's going to be a similar type of operation. So it's going to be width instead of length times slant 2 divided by 2. Okay, so if you wanted to find the slant of something, you could just really, if you wanted to, you could take a ruler and go like from the tip, the toppity tip of the pyramid all the way down to one of the sides, or the corresponding slant, and that you can measure that directly. But sometimes you'll be given a triangular or a measurement like this. So sometimes need to calculate slant S values. Okay, so if we draw like a side view of a pyramid, I guess it really does just look like a triangle, but sometimes we will get a situation where we just get this measurement here, and let's call that the height. And we are looking for the slant. I'll put that a different color so it's more clear. Orange. So this is the slant that we're looking for. If we wanted to find that, well, we know that over here, this is going to be the height, and we know that this is going to be, this could be this could be like the length over 2. So if we wanted to find the S in this situation, Pythagoras theorem, we know that S is going to be of height squared plus L over 2 squared. Okay, and that would be your measure for the slant. This could also be I'll write that in a different color, maybe in green. Might also be width over 2 for the other sides. So in this case, S would be equal to height squared plus width over 2 squared. Okay, so these would just be some of the procedures. Slant is the only thing that might be difficult to find, but honestly, the easiest way to visualize surface area problems is to unfold or get the net of the shape of this. In this pyramid, we have this pyramid as an example, and you would just unfold it and find the area of all the components, and you might need to do some work to find some of these measurements, but once you find them, it's a fairly straightforward process. Okay, so yeah, so this would be how you find it. Actually, we can even simplify this equation down even more. Let's do that in purple. So if we do surface area is equal to R, which is L times W, let's actually do them in their respective colors. So we got green for R, LW, that means L times W, plus 2LS1 over 2. Those 2's cancel each other out. And then plus blue, which is going to be 2 over 2. So those 2's cancel out. And we have WS2. Okay, so all in all, we have a final equation for surface area that's going to be equals LW plus LS1 plus WS2. Okay, S's are the slants, length and width are the base measurements of the base of the pyramid, and once you have this equation, you can easily find the surface area. You just need to possibly get the slants in a different way, but you know, it's fairly straightforward. Okay, yeah, and they got precisely the same answer, so yeah, this solution is great. The above solution is good. Sometimes slant will be given, and actually no, because if the slant is given, then you should probably already see exactly like how we could add all this up. Okay, so the above solution, that's good.